Hi everyone, welcome back to Real Estate Redefined, a web series brought to you by Cisco's Hybrid Work Center of Excellence team. My name's Murray, and I'm joined by my colleagues Ansar and Ryan in delivering this episode to you today. In our fourth episode of the web series, we will be discussing the switching infrastructure needed in an intelligent space. As a recap of previous episodes, in our first episode, we broke down the concepts of delivering a smart building. In our second episode, we expanded on the aspects and considerations taken in deploying a converged network architecture. And in our third episode, we covered and discussed the basics of energy networking. For those returning visitors, thank you so much for continuing to watch and learn from our web series. We hope these episodes are helping you and your colleagues understand what is possible with technology and what the future may hold for the built space. For those who are just joining us for the first time today, please make sure to check out our YouTube to watch the previous episodes in the series. Now let's jump into episode 4. In today's episode, we are going to be discussing switching infrastructure. To break this down further, our team will be discussing the foundations of modern workspaces, how switching infrastructure can empower these spaces, just a few of the many great features available from Cisco switching, and finally, show a demo of how to enable your switch to act as an IoT gateway. Ansar, can you start off by sharing the foundation of modern workspaces?
Thanks, Maury. It is great to be here today to discuss how Cisco switching infrastructure empowers the modern workspaces. The network is now the foundation for today's intelligent buildings, converging both the IT and OT systems. It is not just about connecting devices, it is about integrating physical and digital worlds seamlessly. In a smart building, physical elements like lighting, shading, HVAC, and security are traditionally managed by the OT systems. On the other hand, IT elements including laptops, computers, handheld devices, video conferencing devices, and servers were managed by the IT systems. In the past, this IT and OT were often separate and siloed. However, with the rise of Internet of Things, the IoT, that's no longer the case. More and more devices are connecting to the network, requiring a seamless communications, regardless whether it is IT or OT. They need to communicate seamlessly each other. And the network infrastructure act as the backbone, simplifying the integration of this IT and OT in the modern building. The switches are recognized as the most critical element in these overall ecosystems. In this episode, we will explore how Cisco switches, with their intelligent and rich features, empower modern office workspaces. Without a doubt, switches connect everything together, acting as the main support for networks. But Cisco switches are more than just the regular network devices. They are the powerhouse behind modern building intelligence, playing a big role in making buildings and workplaces smart and sustainable. They connect, power, manage, and secure various systems in a modern building. For example, the latest Catalyst 9000 series switches pushes the boundaries of what is possible. These switches empower various IoT sensors and devices to excel in real-time data collections. Going beyond the basic switching capabilities, these switches act as an intelligent gateway for your wired IoT world, being able to host application on the switch itself for edge processing and then streaming all those real-time data collected from all those IoT endpoints instantly to a platform like Cisco Spaces. Cisco Space is a cloud-based platform, and it provides valuable insights as well as tools for managing and optimizing as well as securing your workspaces. And it leverages data from your existing Cisco network infrastructure that includes access points, switches, and other Cisco devices like collaboration devices, Meraki cameras, and IoT sensors. Supplying and managing power for thousands of IoT endpoints in a modern building can be a significant challenge. This is a common scenario nowadays. And often it involves you running line voltage or providing battery power to those thousands of those endpoints. Cisco 9000 series switches stand out with the capability to deliver up to 90 watts of power per switch port. It means you are able to send more power through the standard Ethernet cables, and it helps to power various smart building sensors as well as devices such as like LED lights, window blinds, IoT sensors, security cameras, and even office furniture like work desk. Think of it as you eliminating the need for separate line voltage or the power cables to those thousands of endpoints, simplifying the installations and reducing the mess for a cleaner, more sustainable, and efficient setup. Let me talk a little bit about the security requirements in a modern building or intelligent building from a switch perspective. Now, with these thousands of IoT endpoints connecting in this building, securing them brings a significant challenge. The network edge is the first line of defense, where policies apply to determine who or what has access to your network and also to sense any suspicious activity. And it is regardless whether the traffic is encrypted or not. It takes only one data breach to affect your entire organization. So, with so much potential nowadays for unauthorized access, it is absolutely critical to have a trusted solution to identify and control what gets on the network. Cisco switches plays a vital role in enhancing the smart building security by serving as a primary defense at the network edge. With its rich LAN security feature set, including its extended ability to host and run even a containerized ASA firewall within the switch itself, and as well as the compatibility to operate with the comprehensive set of other Cisco security platforms and tools, it clearly supports the zero trust model implementations. That is actually essential to identify and verify all those IoT endpoints connecting to the network. It needs to establish a policy as well as a segmentation to ensure least privilege access is provided based on the endpoint and user type. And additionally, it must continuously monitor the endpoint behavior, ensuring the compliance and as well as prevent any potential threats like ransomware. In summary, for environments involving the connectivity and the convergence of these various IT and OT systems, it is absolutely crucial for businesses to choose the right switch product with the appropriate level of security feature to ensure that there is nothing compromised in the network foundation itself.
Thanks, Ansar. As we look at converging both IT and OT systems on our switching infrastructure, we begin to take advantage of IT best practices. So being able to secure the infrastructure, being able to transport the infrastructure, and take advantage of a real world deployment and all the data that's associated with it. So as we look at our lighting platforms, being able to bring in occupancy sensors, being able to bring in environmental sensors that are located throughout there, and then as well as being able to now power those traditional AC line voltage solutions over our switching infrastructure. So creating that very flexible and agile deployment to be able to combine both data and power and now enhance new possibilities within a build space. A couple examples, like I previously mentioned, PoE lighting and shading. So being able to reduce the amount of infrastructure, being able to power multiple shading components and multiple lighting components over a single category cable, as well as being able to now harness all the telemetry and all the data that's now created from those solutions and being able to transport that in a very uniform and concise fashion, creating that feature-rich environment and that data-rich environment, and being able to provide context back into each of those what would traditionally be siloed sub-solutions, and now into that uniform, converged IT/OT infrastructure. If we look at the important role that a network plays in day-to-day connectivity, we see the mission-critical nature of delivering all of these solutions on a day-to-day basis. A Gartner study showed that a typical 1 hour outage in an enterprise network cost the customer over $300,000 due to that outage. So you see that it's a very costly impact for any sort of downtime that will happen on an enterprise network. If we look at it from a Cisco perspective, with the critical nature of this and that being built into our products, with StackWise Virtual being able to interconnect switches for high availability and disaster recovery and redundancy, as well as power supplies, and being able to do in-service software upgrades, being able to have those particular switches running while the service enhancements are done on a field level. Critical nature is part of our business and what we do, and we understand that the critical nature of all of these solutions delivered is required in today's landscape. Outages and downtime created by unmanaged and non-resilient architectures are very costly on day-to-day operations and the bottom line.
Thank you, Ryan. Now I'd like to quickly talk about one of the standards that is important to know about when it comes to using switching infrastructure in the built space. The IEEE 802.3 BT standard for Power over Ethernet is the third revision to the IEEE standard that specifies low voltage power transfer to network devices. The first IEEE PoE standard, or 802.3 AF, was released in 2003 and was able to provide 13 watts of power to devices. This was increased to 25.5 watts by 802.3 AT that came out in 2009. With 802.3 BT, the amount of power available for devices has drastically increased, with 90 watts delivered out of a PSE and 71.3 delivered to the end device. This now enables a myriad of new applications, such as many different building systems like lights and shades. From a Cisco switching infrastructure standard, we have a few different series of switches in the chassis and stackable form factor. The 9400 series is the chassis form factor, and in the stackable form factor you can choose from either the 9300H or the super powerful new 9300X series switch. Now, if you plan on using Cisco switching primarily for 90 watt use cases, please make sure to look at the power supplies you are procuring. The recommended supplies on the chassis form factor are the 3200 watt power supplies, which are available in both AC and DC input power. For the stackable form factor, it is recommended to procure dual 1900 watt power supplies. Depending on the use case, you can make use of these power supplies in different configurations. For the sake of building systems, we will split into maximum available power out of a port with combined mode, or redundancy for the devices being powered. From a redundancy standpoint, if you're using combined mode in a stackable format, you can take advantage of stack powering your switches in addition to the typical network stacking to allow for power sharing in the instance a power supply were to fail. There are also features that can be configured on the port that allow for power delivery to be a priority for the switch over providing connectivity to devices. The first feature, Fast PoE, allows the switch to provide faster power recovery should a switch need to be turned off completely and brought back online. Perpetual PoE allows for uninterrupted power delivery to endpoints when the switch needs to be reloaded for reasons such as a software update.
Thanks, Maury. For nearly 2 decades, Gigabit Ethernet has been the backbone of our networks. It is reliable, affordable, and widely deployed. In campus, branch office environment, if you largely look, vast majority of the endpoints that connected to access switches have 1 gig network interface card. They just work fine, provided most of these switches now able to provide non-blocking 1 gig connectivity to those endpoints. Now let's talk about the wireless access points that is directly connecting to an access switch. When we were running Wi-Fi 4 and older version of access points, 1 gig connectivity was sufficient because the data rate supported by those access points were less than 1 gig. But with the rise of Wi-Fi 5, then Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7 upcoming, the demand for bandwidth has exploded in the wireless sector. So still providing 1 gig connectivity between the switch and then those latest generation access points, definitely not ideal. Gigabit connection has become a bottleneck. So what? This bottleneck creates a drag on performance in the wireless sector, impacting everything from user experience to business productivity, especially in a high density environment. And also with the current trend of implementing a wireless first strategy by many organizations, Wi Fi has become a primary medium for many IT work area use cases. So the market demanded an innovative solutions that can support speed greater than 1 Gbps. To resolve this issue, Cisco introduced multi-gigabit capable products such as like the switches and access points, so they could achieve much higher speed. For example, Cisco's latest Catalyst 9000 series multi-gigabit capable switches can provide up to 10 Gbps of data connectivity, along with providing up to 90 watts of power for those endpoints that are bandwidth as well as power intensive. But the speed upgrades that happen to the wireless access points and as well as the switches have quickly outpaced the refresh cycle for cabling. Much of the Ethernet cabling deployed worldwide today is limited to using 1 Gbps at 100 meters. So businesses could have a tsunami of traffic coming from the latest Wi-Fi network with no way to deal with as it hits the existing access LAN infrastructure. And it is understood that upgrading cabling infrastructure from an existing copper cables to a higher speed copper or a fiber cables can be a very expensive process. And this could prevent many businesses from capitalizing on these new capabilities. This also raised questions: how can you overcome this bottleneck and capitalize on this transformation of potential of Wi-Fi 6? I'm not sure how many of you listening to me are aware of the fact that Cisco multi-gigabit solutions operate at a distance of 100 meters using the existing Category 5E or Category 6 cables, which constitutes more than 95% of the installed cabling today. Multi-gigabit switch ports with auto negotiation on can actually operate at 100 Mbps, 1 Gbps, 2.5 gig, or 5 gig speed on an existing Category 5E cables. And it can also operate at 10 gig speeds over newer Category 6A cables. As a result, if you're running Category 5E cables now, you can still bring up your speed of the wireless up to 5 times. So in short, Cisco multi-gigabit Ethernet switches as well as the access points let you radically increase the access speeds and as well as the flexibility in your workspace with no upgrade to your existing access cabling. Now let's take a quick look at the Cisco multi-gigabit capable switches and access points. This is not an exhaustive list, but it includes some important ones. On the left, we have a list of Wi-Fi 6, Wi-Fi 6E access points indicating the number of mGig ports, uplink speed, as well as the PoE power they can support and require to operate. Let me briefly touch upon one of the models, Catalyst 9136 series Wi-Fi 6E compliant access point. They come with a dual multi-gigabit Ethernet port, providing power redundant uplink ports, each with a speed up to 5 Gbps. All the speeds supported on the Category 5E existing cabling, or you can choose a latest cabling such as like Cat 6A to provide a 10 Gbps connectivity. Redundant powering ensures uninterrupted performance during the failover. So these APs also have built-in sensors to measure air quality, temperature, humidity, which helps to provide environmental metrics for your modern workspace. To meet the requirements of these various access points listed on the left side, including the PoE power and their uplink port speed, such as like 5 gig per port, you will definitely need a switch that are compatible with it. So the switches listed on the right side include both the fixed as well as modular form factors from the Catalyst as well as Meraki families. And they all are multi-gigabit capable. And I would like to highlight one of the latest multi-gigabit switch models or series from a Catalyst family is Cisco 9300X series, purposefully built for secure Wi-Fi 6, Wi-Fi 6E high-speed access point and beyond, and with the 90 watts PoE support as well. It features high-density MGig ports with the data rate supported up to 10 gigabit, making it really an excellent choice for intelligent, smart buildings deployments, and also for workspaces promoting Wi-Fi first strategy, especially in the IT use cases.
Thank you, Ansar. Another feature now available on the Cat9K infrastructure is the ability to host apps. These apps could be IT operations monitoring tools such as Thousand Eyes, apps that enhance visibility and security enforcement, cloud gateways that provide serverless edge computing that helps reduce latency, or third-party app hosting for customer-specific use cases. This app hosting can be managed either by the CLI or Catalyst Center and uses existing hardware to help save bandwidth usage on your network. I'll pass it on to Ryan to go into more detail on how we at Cisco are using this app hosting in our own offices for an OT use case.
Thanks, Murray. Building upon our switches now being able to host applications directly on our switches, we begin to take advantage of multiple different types of distributed architecture down to our switches. One example of that would be IoT wired gateway. This application is initiated through Cisco Spaces and then down through a Spaces connector, which is a small, lightweight VM located on site or in a data center. And then that allows an application to run natively on that switch. We're able to have SSDs, which are located on the back of the switch, to be able to house those applications and being able to run multiple different applications on that distributed architecture. So looking at having each switch act as a distributed compute. So taking that IoT gateway, we're now able to look at all the wired devices that are now connected to that particular switch. And we're now being able to transport and normalize all of the data that's associated with those connected devices up through the connector and then through Cisco Spaces. From there, we're able to represent that in Cisco Spaces through smart workspaces or our other applications that are contained in Cisco Spaces. And then also being able to push out that telemetry through our Firehose API to any third-party application, such as Power BI or Tririga or some sort of workplace management tool. Building upon the network acting as a sensor and taking that IoT gateway that's now deployed to that switching infrastructure, we can look at different outcomes and different use cases that we're now being able to unlock by having that distributed architecture. We take the example here, is what we have is PoE lighting. If we look, now we're able to provide both power and data to the solution via 90 watt PoE. We can leverage the IoT gateway that's now deployed to that switch and consume all the data that's now created through the PoE lighting solution, such as the occupancy sensors, environmental sensors, the fixtures themselves, and the gateways. All this telemetry that's now created through that, we bring that up via CoAP, which is standard protocol, through the Spaces connector app, up into Cisco Spaces, and then now this is all presented into Cisco Spaces. Being able to leverage that data highway and that data architecture for a very seamless and robust installation and taking advantage of IT best practices and unlocking new possibilities. We'll go ahead and log into our Cisco Spaces account. And from here, we will go ahead and choose our tenant that this is going to be associated with. And from here, this will bring us to our dashboard. Moving over to our wired networks, we're now able to see the connectors that are associated with this tenant that are deployed, any switching infrastructure that would be associated this as well. And then we can look at our connector uptime. So if our connector is currently online, making sure that it's deployed and it's connected to our Cisco Spaces instance. Moving over to our IoT gateway. From there, we can add our wired gateways. From here, you'll see a small prompt that comes up which shows you the requirements in order to deliver this IoT gateway down to the switch itself and the switch models that are compatible with the IoT gateway. We'll go ahead and click on Next. This will do a pre-check to make sure that the connectors are online and all of our licensing prerequisites are in order. And then from there, we go ahead and click on Activate. This can take up to 30 minutes to go ahead and complete the activation and the deployment of it. But once that's finished, we can go ahead and now have that IoT wired gateway associated with that particular switch.
In this episode, we explored how Cisco switching infrastructure empowers the modern workspace, serving as the critical backbone and simplifying the integration of the IT as well as OT in a successful, intelligent building. However, deploying and managing that infrastructure, which includes large quantity of devices, can be a complex and a time-consuming task without the right set of platforms and tools. This is where network management platforms like Cisco Catalyst Center and Meraki dashboards comes in. These platforms provide single unified interface to streamline the management, enhance overall performance, and as well as security, and ensure your network infrastructure supports your business goal. When it comes to you managing network infrastructure, Cisco primarily offers two distinct approaches. Either you can choose a platform that offer on-premise management, which is Cisco Catalyst Center, also formerly known as DNS Center, or choose a cloud-based management with the Meraki dashboard. Choosing the right one depends on your specific needs and preferences. And many of our customers use both options. Additionally, with the latest capabilities, you can monitor or manage selected models of Catalyst devices through Meraki dashboards while keeping others on premises, still managed via the Catalyst Center or the CLI itself. This hybrid options provides flexibility for organizations looking to transition to the cloud gradually or manage the diverse needs within their network today. There are two key ways to integrate Catalyst 9000 series switches with the Meraki dashboard. One is managed mode, the second is the monitored mode. Now, with the monitored mode, these options offer read-only access to your Catalyst switches through the Meraki dashboard. You can view the device status, health, as well as basic statistics. But all configurations management still remains on the switch itself. You have CLI access. It can be managed through the CLI or it can be managed through the Catalyst Center. This mode is ideal for organizations who want to leverage Meraki's dashboard visibility and reporting capabilities while they still want to retain a granular control over their Catalyst switch configurations to do any kind of an advanced automations or configurations with it. Some of the examples of these switches supported in the monitored mode includes the 9200 series switches, 9300 series switches, and 9500 series switches. To see the exact model supported from this series, refer to our data sheets. Managed mode on the other side, the Catalyst switches become fully managed by the Meraki. So similar to the native Meraki devices. So when you put the devices in a managed mode, you can configure and control everything through the Meraki dashboard. including the firmware upgrade, security policies, as well as the traffic management. This option provides the full Meraki experience with its centralized management, automation, as well as cloud-based simplicity. And some of the examples from this category includes 9300 series switches, Catalyst 9300 series switches, and this list can actually grow. In summary, both the Catalyst and Meraki offer a wide range of switches and access points and other network devices, allowing you to mix and match based on your needs. Ultimately, the best approach depends on your unique requirements and priorities. Consider factors like the network size, complexity, security needs, IT expertise needs, as well as the budget when making your decisions to choose either a product as well as a platform to manage those products.
Thank you all so much for joining us for today's episode of the web series. If you just joined us for the first time today, please make sure to check out our previous episodes on YouTube. If you enjoyed today's episode, make sure to register for future episodes of the series. Please make sure to come back next month for episode 5, where we will be covering wireless infrastructure in the built space.